Recall that actual parameters are the parameters passed to a function. Like for example, here is the calling procedure for a function add, right? This is the way you call a function, right? And here is the definition of this function add. When you're calling this function with m and n as the parameters, then the value of m will get passed to the variable a and value of n will get passed to variable b. This is how it works, right? So these parameters are called as actual parameters because these are the parameters passed to a function, and these are called as formal parameters because these are the parameters received by a function, right? As they are receiving the values, therefore they are called as formal parameters, and they are sending the values, therefore they are called as actual parameters. Let's first try to understand what is call by value. Here values of actual parameters will be copied to formal parameters, and these two different parameters store values in different locations. We have these two variables x and y. Let me declare these variables over here, variable x and variable y. Variable x contains value 10 and variable y contains value 20, right? What we are exactly doing in this calling procedure, we are passing the values of x and y to the function definition, which is available over here. These values 10 and 20 will get passed to these variables x and y. Let me declare these variables over here, x variable and y variable. These variables now contain value 10 and 20, right? Now inside this function, we are changing the value of x to 20, that is what we are doing here, and we are changing the value of y to 10, that is what we are doing here. So variable x will now contain value 20 and variable y will contain value 10. Now please note down that these variables are local to this function. When this function procedure finishes, we get back to this calling procedure. Then these variables will get destroyed, right? And whatever the changes you made in these variables will not get reflected back to these variables. So if we try to print the values of x and y, then the input is x equals to 10 and y equals to 20, which are the original values. This is what we need to understand about the call by value. In call by value procedure, you're simply passing the values to the variables and not the variables itself. So whatever the changes you made to these variables will not get reflected back to these variables. This is called call by value. Now let's try to understand what is call by reference. Here, both actual and formal parameters refers to same memory location. Please note down this point. Therefore, any changes made to the formal parameters will get reflected to actual parameters. Whatever the changes you made to the formal parameters will get reflected to actual parameters. Also, here instead of passing values, we pass addresses. We are not passing the values, we are passing the addresses. Like for example, here we have two variables x and y. Let me declare them over here. Variable x and variable y. And they have addresses 1000 and 2000 respectively. Now the value of x is 10 and value of y is 20. Now in this calling procedure, you can notice the difference. Here instead of writing x and y directly, we are also mentioning these ampersand operators, which are also called as address of operators. That means we are simply passing the addresses of these variables instead of passing the values. Here ampersand of x means address of x and ampersand of y means address of y. Therefore, in the definition of the function, address of x and y is received instead of values. Okay. Now as addresses are received by this function, therefore some special kind of variable is required to store them. As if we simply declare a variable over here in the parameters list, then they are not capable enough to hold the addresses. Therefore we require special variables which are also called as pointers. Pointers are those variables which can store addresses of some other variables. This is the way you declare a pointer. We'll talk about pointers later in greater details, but right now it is important for us to know that pointers are those variables which can store addresses. Let me declare these pointers over here. This is ptr1 and here is the ptr2. ptr1 stores the address of variable x, which is 1000. Therefore, 1000 will get stored inside this pointer ptr1, and ptr2 will store the address of variable y, which is 2000. Now inside this function we have two statements, star ptr1 equals to 20, star ptr2 equals to 10. Now here is one important point we need to understand. Whenever we simply write a variable, suppose x, then this simply means that we are accessing the content of that variable. Now if we write simply ptr1, that means we are accessing the content of ptr1, and the content of ptr1 is the address of the variable x, right, which is 1000. If we write star in front of ptr1, this simply means that access the value of that particular address. Okay, this particular operator is called as dereference operator, which is just opposite to this operator ampersand. It is also called as reference operator. So what does it really mean? When we simply write ptr1, we are accessing the content of ptr1, which is 1000. Therefore ptr1 will get replaced by 1000, right? Now when we write star in front of 1000, that means we are trying to access the content of this particular address 1000. This means we are mapping 1000, right? And this simply means we are trying to access the content of variable x, which is 10. Now here I'm assigning 20. That means we are changing this value to 20, right? Similarly, when we are writing ptr2, we are trying to access its content, which is 2000. And when we write star, we are simply mapping it. That means we are mapping this location 2000. And we are trying to access the content of this particular memory location, which is actually variable y, right? Now as we are assigning 10 to it, therefore this value will get replaced by value 10. As this function finishes, therefore we come back to this calling procedure, and after that we simply print the content of x and y, as now in this case the value of x will get changed to 20 and value of y will get changed to 10. Therefore the output is x equals to 20 and y equals to 10. So this is the major difference between a call by value and call by reference. When we are saying call by value, we are passing the copies or values of the variables to the other variables in the definition. And when we are saying call by reference, then in that case we are passing the addresses to the other function which are received by the pointers. And when you are passing the addresses to the function, then you can access those addresses and can change the content available in those addresses, which will get reflected back, and hence we can observe the changes even after function finishes. Okay friends, this is it for now. Thank you for watching this.